Okay, now what we are doing is lateral shift. Now what exactly is lateral shift? So you guys will understand in just a moment. Now for lateral shift, what we do is, so first we'll take a rectangular glass slab. Now once we have a rectangular glass slab, so let's call that as W, X, Y and Z. So this is a rectangular glass slab. Now every glass slab will have a thickness. So let's say that the thickness of this glass slab is T. Alright. Now for every glass slab, what we are taking is, remember, refraction happens and a little bit of dispersion will also happen. Now what is dispersion? You guys will get to know about that in some time. Now let's assume that a ray of light is incidenting. Now before that, remember the laws of refraction. First we need to draw a normal. So let's say this is the normal. Okay. Now what we have is some ray of light should incident at this particular point, right? So let's assume that this is coming at some angle. So this is the incident ray. Now once incident ray comes, then we need to find some particular angle here. Let's say this is the angle of refraction. So this is the refracted ray. Now again here we need to draw a normal, because once we draw the normal, then only we get to know that what is the angle of emergence. So this is the emergent ray. So this will be the emergent ray. Now what we have, so this one and this one. So let's name it. Let's call this as A, B, C and D. Okay. Now this is I, the incident angle. This is R. See, if this is R, even this will also be R, because these two will be alternate angles, correct? Then this will be E. Now E is equal to I, that is the angle of emergence and the angle of incidence are one and the same. Okay. Now what exactly is lateral shift? Now to understand what is that, first you need to know how this lateral shift works. See, if this glass slab was not there, then this particular ray of light would have traveled undeviated in this particular way, correct? So that means this is the undeviated ray. But because of the glass slab, it is getting refracted. That means from C, it has been deviating. How much of the deviation? That is what we call as lateral shift. So to understand what is lateral shift, so we need to draw a perpendicular in this particular way. So from here to this particular line, if you drop a perpendicular, so let's call this point as, let's say, a P. Now CP is nothing but the lateral shift, right? So we need to take, or we need to consider what is lateral shift for a particular material and then calculate the lateral shift. Okay, now so we need CP. Okay, now what we have, see, if this is angle I and if this is angle R, then this particular angle will be I minus R, right? The whole angle is I, this will be R, so obviously this has to be I minus R. Now very important thing is taking which triangles will help us to get to know what is the lateral shift. Now we need CP, correct? So the triangle which we have to consider is BCP, correct? So in triangle BCP, what we have I minus R and we need CP. So using trigonometry, we'll take sine of I minus R is equal to CP divided by BC, right? So what we need is CP, correct? So we can write CP is equal to BC into sine of I minus R, right? Now BC is not known, so we need to calculate BC. Now to find out what is BC, we'll consider another triangle. Let's say this is BC and let's call this point as E. Alright. Now in the triangle BCE, now we'll consider cosine of R. So if you take cos of R, this will be nothing but BE divided by BC, or you can write BC is equal to BE divided by cos of R. Now what is BE? BE is nothing but the thickness. So we have BC is equal to T divided by cos R. So you substitute this BC in this particular equation. So in this equation, so we will get CP. Now CP is the lateral shift. So let's call it as D. So we get D is equal to T by cos R into sine of I minus R. So this is what you get as the lateral shift in a glass slab. So all the things whatever we need is the thickness, the angle of incidence and the angle of refraction. Then we will get to know what is the lateral shift caused by this particular glass.